Today, we are pulling back the curtain on a piece of invisible technology that honestly runs our digital lives, the authentication token. You can think of it as the secret agent that's constantly proving who you are online.
I mean, really think about it. You log into an app just one time, and for the next week or even longer, it just remembers you. How in the world does it do that securely without bugging you for your password every 5 minutes?
Well, the answer isn't magic, though it kind of feels like it. It's actually a really clever piece of engineering. There's this tiny digital gatekeeper working nonstop behind the scenes, always vouching for you. And we're going to dive into exactly how it pulls that off.
Okay, so the best way to picture this gatekeeper is to think of it as your own personal digital VIP pass. This pass, which we call an authentication token, is what grants you access to all the exclusive, members-only areas of an application.
But here's the thing. This VIP pass, it doesn't last forever. Nope, it has a life of its own. A whole journey, really, with 5 very distinct stages, from the moment it's created to its eventual retirement. So let's follow along on its grand tour. So it all kicks off with number 1, generation, which is basically when the token is born, the moment you log in. Then comes number 2, usage, where it gets to work, doing its job and granting you access. It can get a little extension on its life with a refresh, that's number 3, but it's eventually retired through number 4, invalidation. And finally, it's completely removed during number 5, cleanup.
All right, so when everything is running just perfectly, the token is in what we call a valid state. Your VIP pass is active, right? The bouncer at the digital club door sees it and nods you right on through. It's not expired, it hasn't been revoked, it's really in its prime.
But like I said, these passes, they have a time limit. And once that clock runs out, the token enters the expired state. At that point, your pass is no good anymore, and the system won't let you in until you get a new one.
Now this one is really different from just being expired. An invalidated token is one that's been deliberately canceled. Think of this like the bouncer not just denying you entry, but actually taking your VIP pass and ripping it into pieces right in front of you. This happens when you log out or maybe change your password, or if the system flags a security risk. It is completely game over for that specific token.
So it's pretty clear this digital pass is super powerful. If someone else gets their hands on it, they can literally impersonate you. And that's exactly why protecting it is one of the most critical jobs in all of application security.
A huge part of that security is where the token is stored on your device. Storing it in memory or in secure, HTTP-only cookies, those are the best options. These special cookies are great because they can't be touched by rogue scripts running in your browser. But, and this is a big one, you should absolutely never, ever store tokens in something called local storage. Why? Because it's just wide open to attacks that can steal that token right out from under you. And what about when you're sending the token from your browser back to the server? Well, there are 3 golden rules. First off, always use HTTPS to encrypt the entire conversation. Second, you put the token in a very specific place, an HTTP header called authorization. And third, keep the tokens short-lived. Seriously, a token that's only valid for a couple of hours is way less risky than one that lasts for a whole month.
Okay, so we've got security locked down. But what happens when you have millions of users, each with their own token, all trying to access the system at the same time? I mean, verifying every single one of those tokens from scratch would be incredibly slow. And this is where performance and optimization come into play.
The secret to handling all of this at scale is something called caching. The easiest way to think of a cache is as the system's high-speed short-term memory. So instead of doing the hard work of validating a token over and over and over again, it just remembers the result from the first time, which makes everything else lightning fast. So the first layer of this cache is all about pure efficiency. It stores the already decrypted version of the token. This is how the system avoids having to do a really costly, computationally expensive task on every single API call. It decrypts it once, and then it just remembers the result. Simple, but effective.
Then you've got this second layer, which is like a security checkpoint. It's basically a block list. So when you log out and your token gets invalidated, its unique signature gets added to this cache. That way, the next time that same token tries to get access, the system can instantly say, "Nope, sorry, you're on the block list," without needing to do any other checks.
This brings up a really fascinating problem. If a token is just about to expire, you definitely don't want your app to suddenly stop working right in the middle of something important, forcing you to log in all over again. So how do these systems handle that transition seamlessly?
The solution is this really clever strategy called a grace period. Let's say a token has a 2-hour lifetime. the system doesn't wait until the very last second. Instead, it creates a little window, say the last 5 minutes, and that's the grace period. When a request comes in during that window, the system lets you in, but it also proactively issues you a brand new token behind the scenes. It's brilliant, and it ensures you never even notice a disruption.
Whew! We have covered a lot of ground, from the token's lifecycle to security and performance. So let's wrap all of this up into a simple, actionable little cheat sheet.
So the really crucial points are these. For security, store your tokens safely, never ever in local storage. Only send them over HTTPS and keep their lifetimes short. And for performance, use caching to avoid redoing heavy work and use a grace period to refresh those tokens before they expire. If you just remember these 5 points, you pretty much understand the core principles of modern token management.
At the end of the day, these digital keys are the foundation of trust on the internet. They're constantly working, 24/7, to protect your identity and your data. The systems that manage them are incredibly sophisticated, but security is always a shared responsibility. So it kind of leaves us with a final thought. What are you doing to keep your digital kingdom secure?